We have 13 good papers in this special issue, but some of them are online and some of them are waiting and in the process of production. Also, for this special issue, we wrote editorial, and in this editorial we discuss measurement and structural model assessment based on new development in partial least squares or PLS literature. I also publish some work in using PLS-SEM with different software. This is one of my first papers that I published with the tourism management perspective with developer of WarpPLS. The WarpPLS is a software that today but for PLS there are different software. WarpPLS, Smart PLS, Adonco PLS, Prof, and different software. But today I will discuss and illustrate briefly about WarpPLS software. This is one of the first paper that I published with the Netcook. Professor Netcook is developer of WarpPLS. This is another paper I used also WarpPLS and published in Habitat International. And also I have some other papers that all these papers I use WarpPLS software and reports result of PLS assessment of measurement model and structural model in these papers. Also, this is one recent paper published in 2018. We published this paper collaboration of Marcus Sarstedt and Christian Rengle. Christian Rengle and Marcus Sarstedt are two prominent professors in PLS-SEM literature. And in this paper, we review all papers that use PLS-SEM in hospitality literature. And at the end of this paper, we propose a guideline for different parts for data characteristic and assessment of measurement model, assessment of structural model, and some advanced use of PLS like assessment of mediator and moderator based on recent literature in PLS-SEM. So this paper can be used as a guideline to report, to assess a framework and model using PLS-SEM and report the result based on the recent literature and recent development in PLS. This paper published in the International Journal of Contemporary Hospitality Management. Okay, this is a very brief introduction. Now let's start the first session. I try to discuss in two sessions. Now in your time is 1:08. I try to finish the first session. In the first session, discuss some basic things about PLS-SEM and how we can assess the measurement model and a structural model. And after a small break, second session, we can talk about a bit more advanced topic like assessment of higher order construct or assessment of mediator and moderator. So in first session, focus more on basic part of structural equation modeling. This is the outline that I try to cover, why we prefer SEM and what's the characteristic of SEM, what's the component of SEM, and what's the difference between reflective and formative construct and also covariance-based SEM and PLS-SEM. And the reason that we need to choose PLS criteria for assessment of measurement model and structural model, and also in second session some brief explanation and criteria to establish and assess higher order construct, assessment of mediator, and assessment of motorist. Okay, let's start why we use SEM. Structural equation modeling in the literature called second generation of data analysis compared to first generation. First generation that we perform by some software personalization like multiple regression and ANOVA, and some statistical techniques. We perform by some software like SPSS. That called the first generation of analysis. Compared to that first generation, SEM called second generation because of two main characteristics, two main reasons. The first, SEM is able to deal with a framework with different layers. In first generation of analysis, just we are able to perform a framework and model with one layer and one dependent variable. If our dependent variable change to 2, and we have different layers, a framework with 2 or 3 layers, some variable, some independent variable, affect on dependent variable, and again, these variable affect or influence on other variables. So we have, for example, some antecedent, some independent variable, and some dependent variables. So we are not able to use first generation. Or if we want to use first generation, we need to perform analysis in some different steps, 2 or 3 times. But the first characteristic of structural equation modeling, we can handle a framework with different layer and different number of dependent variables, and no need to run a framework, a model, divide a model in 2 or 3 different models and run 2 or 3 times. So this is the first characteristic of SEM as a second generation of data analysis. Another important characteristic of SEM is SEM can involve and can work with latent variables. Latent variables, especially in social science and also in other area of science, we work with some constructs, some variable like beliefs, some like intention, some feeling, like feeling. We use satisfaction, we assess leadership, we assess loyalty in our framework, and in the framework we work with this type of variables. This type of variables or construct are not directly observable variables, right? For example, when we want to assess intention, when we want to assess belief, satisfaction, or loyalty, we need to use some items to assess satisfaction, and based on these items, we can measure, we can assess satisfaction, we can measure intention. So intention, satisfaction, loyalty, these type of variables that measure or assess based on some observable variables, some observable items, these called latent variables, right, or unobservable variables or construct. These variables measured by observable items. For example, we ask respondent about satisfaction, for example, satisfaction about hotel, guest of hotel. So we ask some question: are you satisfied with this hotel? You will recommend this hotel to your friend, will come back to this hotel. So based on this question, we can understand the level of their satisfaction. So we measure satisfaction based on some observable items, but satisfaction here is a latent variable. So the second characteristic of SEM is working with the latent variables, working with latent constructs. So based on these two main characteristics, SEM as a second generation can work and can perform analysis for a framework and a model with different layers, different number of dependent variables, and SEM can work with latent variables. Based on this characteristic, we can define SEM or structural equation modeling as a second generation of analysis that is able to handle this framework with these characteristics. For example, here, if for this simple model, x, y, and z, x measure based on these two items, z also based on z1 and z2, and y, y1 and y2. But we have some relationship between these variables. Okay, if we want to use the first generation of analysis, like multiple regression, for this analysis, we need to run this relationship first time and another relationship in second run, second step. But we can handle this framework very easy by structural equation modeling and using SEM. Okay, so SEM is a family of a statistical model that seeks to explain the relationship among multiple variables simultaneously, or it's examining the structural interrelationship and construct or unobservable or latent variable or construct. Okay, before going to perform analysis by SEM and using SEM, we need to know some concept in the when we apply a structural equation modeling. The first thing is the exogenous and the endogenous latent variable or construct. Exogenous construct, okay, show you here. Exogenous construct is identical with the independent variable and similar to independent variable. And the endogenous construct is similar to dependent variable, but not same. Exogenous construct is the construct in our framework that no arrow from other construct point to this construct. So we call this construct exogenous or exo construct. So exogenous construct is first level of our framework. No structural, no latent variable or construct before that point to this construct. So we call this construct exogenous construct. But if we have a construct that some arrows from other construct point to this construct, like this one, like attitude here, this construct is called endogenous construct or endo construct. So if we have, for example, another layer here, we have two more variables here, and attitude go to loyalty and satisfaction, for example, right? So also these two new variables, satisfaction and loyalty here, are called the endogenous construct because the arrow go from attitude to satisfaction and loyalty. And these two variables somehow appointed from other construct to this construct. So also this construct should be called endogenous construct or variable. So this is the first definition we need to consider when we apply a structural equation modeling, endogenous and exogenous. Another thing is inner model and outer model. Inner model and outer model in SEM, outer model or measurement model refer to relationship between observed variable, observed item, and latent variables or construct, right? So the relationship between items and a construct called alter model or measurement model. Here, relationship between these item, this observed item, and this construct, and also here, relationship between these items and this construct called alter model or measurement model. So when we say alter model or measurement model, we refer to, we talk about, and we explain, we discuss within a construct, inside a construct, relationship between observed item and construct. And so we call this relationship alter model or measurement model. But if we refer to relationship between constructs, for example, here there are three constructs in our framework: ease of use, usefulness, and attitude. Relationship between these latent variables or these constructs called a structural model or inner model. So alter model or measurement model refer to relation between observed item and construct. An inner model and a structural model refer to relationship between construct and our framework. So this is another concept that we need to know when we work with structural equation modeling. For example, here also you can see this relationship indicator 1, 2, and 3 with this construct, this relationship called the measurement model and alter model, also this one and this one. And relationship between these three constructs called inner model or structural model. Okay. So this is two main concepts that we know when we apply structural equation model. Okay. Before going to the next step, here I want to show, here you can see the indicator and the items of this construct. The arrow is from indicator to construct, right? But this one, the direction of arrow is from construct, from latent variable to item, observed variable or indicator, right? So we have two different directions for measurement model or alter model of these two constructs, right? So there is this, so it should be some differences between these two type of construct. Okay, now we can go to next step. Next step is reflective and formative construct. So we have two main types of construct, two main types of latent variable when we are working with, when we are using structural equation model. Reflective and formative. Later, very briefly, I will explain. We have under formative, we have two types of also construct. These two types of construct called causal formative and composite formative construct. And also there are some differences between these two types of formative construct. But in we can categorize in two main categories: reflective and formative. Okay, what's the meaning of reflective and formative? Before explaining this equation and direction and some characteristic of reflective and formative, just want to show one example. Okay, here there is a variable called satisfaction. Okay, we want to measure satisfaction of guests of a specific hotel, about hotel A. right? We can apply two types of items, two types of observed variable, or the items mean the question. For example, if you apply a questionnaire, the question in your questionnaire, you can apply two types of questions for assessment and measurement of satisfaction. Okay, the first one is, you want to measure satisfaction. I feel well in this hotel. I'm always happy to stay in this hotel. Or I recommend this hotel to others, right? This is one type of question that you apply to measure satisfaction. Also, you can apply another set of indicators and another set of items to measure satisfaction. Okay, this is the second set of items. It's different with this set of items to measure satisfaction. This set of items, okay, you ask about service quality, right? The quality of service. The service is good or not, and ask the guest rank the quality of service in this hotel. Second question is about personnel. The personnel is friendly or not, and ask them to answer based on, for example, Likert scale. The third question, the room is well equipped. We can add another question, for example, ask about environment. Do you like or the environment is hotel is attractive or not? The hotel is accessible or not? So we can add different types of questions, right? So this is another set of variables that we use to measure satisfaction. Okay, you can see a significant difference between these two types of variables. In first set of variables, in first set of items, to measure satisfaction, you can see a high correlation between items. For example, if I feel well in this hotel, definitely I'm happy to stay in this hotel and I recommend this hotel to my friends, right? But this is the nature of these items to measure satisfaction. But what about this set of items, this set of indicators? Okay, if it's possible that the service of this hotel is good and I'm satisfied with service, but the personnel is not friendly, so I'm not satisfied with personnel. The equipment is very well and very good, but the personnel are not friendly. Or service is good, personnel are friendly, and the equipment is very nice, but the environment or accessibility of this hotel is not good, right? So my answer to this question can be different. I can be satisfied with first one, but not satisfied with second one, and also satisfied with third one, but not satisfied with accessibility. So these items measure satisfaction from different perspectives, or each item represent one specific aspect of satisfaction, right? So we are not expected we don't expect that these items be high correlated. The correlation can be very low, right? Because these items are from different perspectives. So we call this type of items that measure satisfaction from different perspectives, we call this type of items formative items. And if the items are high correlated and each item separately can represent the whole meaning of satisfaction. So all items are high correlated, these type of items called reflective. So the nature of these items is reflective and the nature of these items is formative. We measure satisfaction based on these items formatively and based on this set of items reflective. So this is the difference between satisfaction and between formative and reflective. So now I back to this part. Okay. This is the equation that represents reflective item, and this equation and this figure represent formative items and formative construct. Okay. In this one, reflective item, each item, each observed item for reflective construct can represent the meaning of construct. So each item reflects the whole meaning of construct, but plus one error, because we apply different items, diverse items. So each item has one part of each item represents the meaning of construct, and also in reflective construct, each item has another part that is not common between different items. This uncommon part called error. So each item in reflective construct, based on this equation, you can see this part, it includes two parts. This part, lambda 1 multiply lambda 1 construct eta plus error 1. This part is a common part that reflects the meaning of construct, and this part is uncommon part that reflect different and uncorrelated part of item number 1. And also you can see in this equation x2 is lambda 2 plus error, and x3 lambda 3 plus error. So there is one common part in each item that represents the meaning of construct, and one uncommon part that represents the error. The error should be uncorrelated, and this part creates the correlation between different items. The direction of arrow for reflective construct is come from construct to the item, and each item reflects the meaning of construct. So for reflective construct, we can remove one item easily. Why? Because each item separately can represent the meaning of construct. So removing one item is not a big deal for reflective construct. And this one is similar to reflective construct, is similar to factor analysis. This lambda called outer loading or factor loading. Factor loading in factor analysis, or here we call these values, these estimated parameters, outer loading. And squared outer loading represents the common variance of construct explained by item. Lambda 1, 2, lambda 2, 2, and lambda 3 to square of these lambda represents the explained variance of construct on each item, observed item. So this is the meaning of reflective construct. But formative construct, for the formative construct, the story is a bit different. For formative construct, you remember, each item represents part of this construct, not whole meaning, right? And all items together represent the meaning of construct. So in formative construct, the items all together regress construct. So the equation is construct is W1x1. This is part of explained variance by x1, part of construct, that this part of variance explained by x1, WTx2, this part of variance explained by x2, and W3x3, this part explained by x3 plus error. So error for formative construct is defined on construct level. So the variance of construct in formative construct, including variance explained by x1, variance explained by x2, and variance explained by x3, and error term. Error term is missing part of construct, that we don't have any variable to explain this part. Okay, so you can see a fundamental difference between reflective and formative construct. So for formative construct, we assess W1, W2, and W3. We call W1, W2, and W3 outer weight. It's different with loading. So we don't call loading here or factor loading, just we call outer weight for formative construct. And later I explained that for assessment of formative construct, this weight should be just significant. Should be significant to consider x1, x2, and x3 as a significant contributor to establish formative construct. So the direction of arrow in formative construct come from observed item to construct. And the error term is on a structural level, different with the reflecting. Reflecting, the error is on item level, because each item has a common part and error, but in the structural level, all variables together establish formative construct with error term. This error term is missing part, and we don't include in this formative construct. So this is the main difference and definition of formative and reflective construct. Most of time researcher in PLS especially called reflective construct mode A and called formative measurement model mode B. But this definition is based on the recent literature is a bit different, because actually mode A and mode B cannot represent the meaning and nature of construct. Mode A and mode B are the algorithm that we use in PLS to calculate the score of latent variable. But this is in the literature, especially previous years on all literature. This is another type of construct under formative. Under formative, we have two types of construct. Causal construct is like this one, and this one that we discuss here. Service, quality, personnel, equipment, environment, cause the meaning of satisfaction. Cause the meaning of satisfaction. So we can call these type of items and this type of formative construct causal formative. But sometimes in the literature, the items don't cause the construct, but the items establish and create construct without any error. It means the construct, most of the time, the construct is artifact of items. We define some specific items to establish a construct. For example, when we measure, when we want to assess social demographic characteristic of some respondent, we can put age, education, and household income here to establish social demographic construct. Also, we can add some more variable to measure and to assess, so to establish social demographic characteristics. So this can be different case to case. When we add age, education, and this household income, it means we establish this construct, social demographic, based on just these three items. If we add another items, so we establish different meaning for this construct. This type of construct called composite construct, and the equation is very similar to formative, but we don't have any error term because we don't have missing part. We know we include all items to measure this construct. So this type of construct is called composite, and there are different criteria with the reflective, with the formative to assess measurement model and outer model of this construct. This figure is from Hensler 2017. It's a good figure and decision tree to understand the nature of construct. Okay, if the nature of construct is latent variable, means the meaning of construct already exists, regardless of our framework like satisfaction. Okay, satisfaction already exists. So you select some item to measure satisfaction. You can select formative items to measure satisfaction, and also you can select reflective item to measure satisfaction. So the meaning of satisfaction already exists. This type of variable, Hensler called latent variable, and divided to two different types. If the items are antecedent of construct, so the item, the arrow come from construct to from item to construct. This type of variable, this type of construct, this type of latent variable called formative in this decision tree. But if the items reflect the meaning of construct, as we discussed before, this is called reflective. But if the construct is artifact, and we create the construct, and the construct doesn't exist before we create it. Okay, this type of construct called composite in this decision tree. So this can be used to understand and to realize reflective, formative, and composite. There are some important points here that I highlighted. These points are from our editorial that we'll publish soon. Now, this editorial is available in ResearchGate, but we'll publish soon for this special issue that I mentioned in Journal of Hospitality and Tourism Technology. So I highlighted some part of this editorial for reflective, formative, and composite. In reflective measurement model, each indicator includes a common variance from the construct and error term. And error term is supposed to be uncorrelated. This is the common mistake that when we apply covariance space and we cannot get good result, goodness of acceptable goodness of fit, we try to correlate the error terms. The error terms are supposed to be uncorrelated. And we correlated this one, we covariate the error term, and we can get good result. So this is a common mistake in covariance space. But the error term in reflective construct are supposed to be uncorrelated. The second one for formative measurement error in formative construct is taken into consideration on the construct level. Okay, and represent the missing indicator. The missing indicator that are not included in formative construct. And for composite construct, the items are ingredients, ingredient of construct. So a composite construct are artifact and error-free, and we based on some items try to establish these composite construct like socioeconomic characteristic or other type of construct that we created and doesn't exist in real world before we create it. Okay, this is a brief explanation of reflective, formative, and composite. Another thing is before discuss the criteria for assessment of measurement model and structural model is difference between PLS-SEM and covariance space SEM. But still, there are some mistakes for using PLS-SEM and covariance space SEM and realize between these two. Okay, covariance space SEM and PLS-SEM are two different types of structural equation modeling. But in view of George Skog and Wald, the developer of covariance space SEM and PLS-SEM, these two methods are complementary, not competitive statistical method. So covariance space SEM and PLS-SEM can be applied for different situations, different contexts. Covariance space SEM or CB-SEM the algorithm that we use for covariance space SEM, like maximum likelihood, try to minimize the discrepancy differences between model implied covariance matrix and empirical covariance matrix from data. So when we apply covariance space SEM, the most important criteria to assess CB-SEM is goodness of fit. Why? Because goodness of fit actually shows the difference between model covariance matrix, the covariance matrix from model from estimated parameters, and the covariance from data, from empirical data. So try to minimize this difference between these two covariance matrices. And maximum likelihood is common algorithm is applied for covariance space SEM to minimize discrepancy. So goodness of fit is one of the most important criteria, different goodness of fit to assess covariance space. But actually, variance space SEM or PLS-SEM, PLS-SEM is a common type of variance space SEM. Variance space SEM or PLS-SEM has different mission, has different objective, different target. PLS-SEM actually focus on maximizing the explained variance of endogenous construct. So PLS-SEM try to maximize the variance of endogenous or dependent variable, and is more prediction-oriented approach. So PLS-SEM focus on maximizing the explained variance of dependent variable, and is very suitable, very good for when the objective of our study is prediction. But covariance-based SEM is not suitable for prediction-oriented studies, right? So this is the difference between covariance-based SEM and variance-based SEM. Covariance-based SEM, also called common factor or factor-based approach, and focus on covariance between indicators of each construct. For covariance-based SEM, we don't focus on score of construct, so it's not suitable for a prediction-oriented study. But PLS-SEM, called composite-based SEM. You should be careful. This is different with the composite construct. You remember we have three types of construct: reflective, formative, and composite. If we separate composite from formative. But PLS-SEM is a composite-based SEM, because actually the algorithm that we use to perform analysis in PLS is the algorithms are composite-based algorithm. Don't focus on common factor or common variance of indicators, but rather focus on composite-based algorithm. So PLS-SEM called composite, and we calculate, based on this composite algorithm, we calculate the score of latent variable and work with score of latent variable. Covariance-based SEM is suitable for theory testing. So the main objective of study should be theory testing when we apply covariance-based SEM, because actually covariance-based SEM compare the covariance matrix from your estimated model and data. So when we want to test and establish theory, establish framework, and establish model in different contexts, covariance-based SEM is best approach and best SEM technique to test the theory, establish theory. But if we want to develop a theory, we combine two theories, add some variable, add the measurement, do some modification in measurement part, measurement model or outer model or a structural model. So we want to develop a theory, combine theory. The objective is theory development, and the objective is we try to maximize, based on development of this new framework, this new model, we want to maximize the explained variance on endogenous or dependent variable, right? So for this type of study, for theory development or prediction-oriented study, we want to predict exogenous construct. We want to predict dependent variable. For this type of study, PLS-SEM is the best, because PLS-SEM, by applying composite and algorithm and calculating the score, try to maximize the explained variance of dependent variable. So for theory development and prediction-oriented studies, PLS-SEM is preferred. And also, if the framework is very complex framework, if your framework and your model is complex model, involve a formative and reflective construct, combination of formative and reflective construct. For this type of framework and this type of construct, also PLS-SEM is very suitable approach compared to covariance space SEM. Covariance space SEM cannot handle complex model and cannot work with a framework including both reflective and formative construct, because actually covariance space SEM focus on covariance between common variance, common variance of items, and the comparison between discrepancy between covariance matrix from estimated model and covariance matrix from data. So for a complex framework and complex model, including both reflective and formative construct, PLS-SEM is a suitable approach. And also the PLS-SEM can work with a model with the smaller sample size, and PLS-SEM also called a non-parametric approach and can work with non-normal data. But these two reasons that some study wrongly have some mistake to justify using PLS-SEM based on small sample size or non-normal data. There are some mistakes in some study. These two cannot be reason to justify using PLS-SEM, but actually PLS-SEM can work with smaller sample size, not very small sample size. Later I will explain something about some rule of thumb for sample size, but and can work with the non-normal data. But the main reason to choose PLS-SEM is prediction-oriented theory development and complex model. We're working with complex model that covariance space SEM is not able to handle this type of framework. There are different software for PLS-SEM and covariance space SEM. Common software for covariance space SEM is MOS and Israel and plus EQS and some other software. But just for covariance space SEM, and I explained covariance space SEM is suitable for some specific situations, some specific framework, not all. And the variance space SEM, there are many software to perform variance space for PLS-SEM. With Smart PLS, WarpPLS, Palanco, and some other software. In this session, we will focus on WarpPLS. Okay. Any questions so far? Okay. Let me check the question. Okay, the question: in order to identify reflective or formative indicator, is important to perform correlation analysis. For reflective and formative construct, the most important is to identify reflective and formative is theoretical support. we need to find a strong justification from the literature and theory that this item and the nature of these items are reflective or formative. Just based on a statistical approach, a statistical technique, we cannot decide this construct is reflective or formative. We need strong justification from the literature to realize reflective and formative nature of construct. Okay, if no question, we can continue for measurement model and the structural model assessment. Okay, let's share again my screen. Okay. Okay, right. Okay. Now we decide based on the justification. We decide to apply covariance, variance-based SEM or PLS, and use WarpPLS software. Okay. When we create our framework and our model, and we decide to use PLS, we need to assess. We need to pass two main steps. Two main steps for assessment of our framework: assessment of measurement model and assessment of structural model. Measurement model or outer model. You remember, measurement model refer to relation between items and construct, and a structural model refer to relation between construct. So we need to assess, we need to apply some criteria to assess measurement model and structural model. For assessing measurement model, for reflective in measurement model level, for reflective and formative construct, we need to apply different criteria for assessment of measurement model. Okay, if our construct is reflective, for assessment of reflective construct or reflective measurement model, we need to check reliability and validity and pass these different steps. The first step, when our framework includes some reflective construct and reflective measurement model, we need to check the loading. The first step is check the loading. The loading, and when we check the loading, outer loading or factor loading for reflective construct, the loading should be higher than 0.7. Should be higher than 0.7. Because if the loading is higher than 0.7, it means square of this loading is 0.5. And it means this item at least explains 50% of variance of construct, right? Remember the equation, lambda 1 and multiply construct and error term. So square of lambda, if the outer loading is 0.7 and the squared loading is will be 0.5, and means the item explained at least 50% of construct. So the first step is for assessment of reliability, assessment of loading, and the loading should be higher than 0.7. But the loading higher than 0.5 also is acceptable if the construct meet other threshold for criteria for composite reliability and for average variance extracted. If composite reliability and average variance extracted are higher than threshold, we can still keep the loading between 0.5 and 0.7. So it means the loading lower than 0.7 can be retained if the average variance for extracted or AVE and composite reliability are higher than threshold. But the loading lower than 0.5 should be deleted for indicator reliability. So the first step is assessment of indicator reliability. The second step is construct reliability or internal consistency. For construct reliability, we need to check composite reliability. Cronbach alpha is a traditional reliability criteria, and more recent criterion to assess construct reliability and internal consistency is ROA. So we need to assess these criteria to check internal consistency, construct reliability. Composite reliability, Cronbach alpha and ROA should be higher than 0.7. The recent literature suggests at least these two. At least these two, composite reliability and ROA. Cronbach alpha is not suitable for PLS because don't consider the loading of items for outer loading. So the most appropriate criteria for assessment of internal consistency and construct reliability, composite reliability, or CR and ROA. And the value of these criteria should be higher than 0.7 to establish construct reliability. Another step or second step is after reliability, assessment of validity. In validity, we have two steps. We need to check two types of validity. The first one is convergent validity. For convergent validity, we need to check average variance extracted, and AVE should be higher than 0.5. So the extracted variance by these items at least should be 50%. The average of the explained variance, of these items by the construct should be at least 50%, or AVE should be higher than 0.5. If composite reliability and ROA is higher than 0.7 and AVE higher than 0.5, we can keep the item between 0.5 and 0.7. So this is another step for assessment of reflective measurements model, and this is a step called convergent validity. The last step for assessment of reflective measurement model is discriminant validity. Discriminant validity, applying discriminant validity, we can assess similarity between constructs. When we include some construct in the framework, these constructs should be enough different. Okay, should be enough different, should be divergent. So we assess discriminant validity. It means we make sure that these constructs are different constructs that involved in this framework. Literature suggested 3 criteria for assessment of discriminant validity. Cross-loading, but cross-loading, recent literature no longer suggests this criterion for assessment of discriminant validity. The most conservative criteria are Fortner-Larker criterion and HTMT ratio. That is HTMT. Yeah, yes. Okay. HTMT, heterotrait monotrait ratio. For Fortner-Larker, later I will show you the square root of AVE. The square root of AVE of each construct should be higher than the correlation of this construct with other construct in the model. And or ADE should be higher than squared correlation with other construct. And the HTMT ratio is calculated based on the correlation between construct and correlation between items of each construct and correlation with other construct. HTMT ratio should be higher than 0.9, or the literature suggested two values for HTMT, higher than 0.85 and higher than 0.9. So, but both are acceptable based on your framework. So, HTMT should be lower than 0.9 and lower than 0.85. So you can apply based on your framework. Some recent literature discuss HTMT is much better and more conservative compared to Forn and Larkin. And still some literature suggests using both Forn and Larkin and HTMT ratio for assessment of discriminant validity. Okay. Later, I will be back to formative. Let's discuss first assessment of a structural model and okay, and perform create a model in WarpPLS and see assessment of structural reflective construct and structural model. That criteria was for assessment of reflective measurement model. The next step or second step for assessment of your model and your framework is assessment of a structural model, relationship between construct. Okay? There are some criteria to assess a structural model. The main criteria to assess structural model is R square of dependent variable or exogenous construct, size and significance of pad coefficient. The next criterion to assess a structural model, effect size suggested by literature to assess a structural model, and also predictive relevance QS square. But recent literature also suggests assess the models out of sample prediction using PLS predict. And this is maybe in the future this be one compulsory part for assessment of structural model. But so far, most of literature suggests these four criteria to assess a structural model: the value of R square, the size and significance of pad coefficient, the effect size, and the QS square. The value of R square, literature suggested different threshold and different levels, different numbers for assessment of R square. For example, 1998 for marketing discipline and area suggested these values. 0.67 can be considered large and higher than this. Between 0.33 and 0.65 can be considered moderate, and 0.19 and 0.33 weak or small, and lower than 0.19 is not acceptable. This is threshold suggested by Chin 1998. But here you can see different thresholds suggested by Cohen. Cohen study suggested 0.26 large, 0.13 and to 0.26 moderate, 0.02 and 0.13 small and weak. So you can see here, based on this threshold, the R square higher than 0.02 is acceptable. Consider small, lower than 0.13. So the threshold is totally different with coin. The value of R square totally related to and depend on your area of research and your framework. If, for example, you work on a study that you are studying some success factors of a dependent variable, right? It means you include all variables that can lead to success of dependent variable. So in this case, in this framework, you expect to get very high value of R square, because R square actually is explained variance of independent variable on dependent variable. So when you include all independent variable and success factor to establish dependent variable, so it means you expect high value of R square. But in another study, especially in behavioral science, okay, you measure your dependent variable is satisfaction, and you just include some variables that lead to or influence on satisfaction, not all variables that lead to and influence on satisfaction. Just you include some small number of variables that create satisfaction. It means the explained variance by these variables you don't expect to be very high, because you know you exclude some other variable, and other variable also can contribute to variance of satisfaction or to create satisfaction, right? So in this case, you expect low value of R square. So R square and threshold for R square totally depend on your area of research and previous study. Especially in behavioral science, always we consider 0.2 as a high R square for dependent variable or endogenous constraint. It's different when we apply a framework with, for example, success factor. So it's the value of R square depend on previous studies, and you need to look at the previous study for R square. Another thing is size and significance of path coefficient. Of course, when you create a framework and some dependent variable that influence on some independent variable or exogenous construct that influence on dependent variable, the path coefficient of the relationship should be significant, and the path coefficient should be high to get significant effect of independent variable on dependent variable. Also for hypothesis testing, we check the path coefficient and significance of path coefficient. So this is the second criterion for assessment of measurement, for assessment of structural model. Another thing is effect size. What's effect size? Effect size, or F square, is the contribution of each independent variable on R square of dependent variable. This is the formula to calculate the effect size. R square included minus R square excluded divided to 1 minus R square included. So we calculate effect size as a contribution of independent variable to R square of or variance of dependent variable, right? So the value of effect size lower than 0.02 is not acceptable. between 0.02 and 0.15 considered small, higher than 0.15 and lower than 0.35 considered moderate, and higher than 0.35 considered large. One thing here maybe is useful to emphasize is, okay, if we get, for example, a significant pad coefficient, but the effect size is lower than 0.02, maybe we cannot consider this relationship as a significant relationship. Yeah, we got significant here, relationship, significant pad coefficient here, but the effect size and the contribution of independent variable, undependent variable is very low. So the effect size show the contribution of the independent, undependent, and the last one is Q square, and the Q square show the predictive capability of your framework, and the Q square should be higher than zero to be considered acceptable for predictive capability of your framework. Okay. So this is a basic criteria for assessment of a structural model and reflective measurement. For formative later, I will be back to formative and explain formative. Now I want to create a framework in WarpPLS, show something about WarpPLS, how we can create a framework model in WarpPLS, and how we can see the result of assessment of reflective measurement model and a structural model, and later formative. Okay. Now I want to share with you a data file. I don't know, I can share maybe. Okay. Here okay. Right, data file. Oh, okay. Just image, PowerPoint, and PDF I can share here. I cannot share Excel file, right? What we can do, Andrew, because I thought maybe we can share Excel file. Okay, I can send let me perform analysis with the WarpPLS with this data file, and in break I will send the data file to your email and you can share with the participants. So you mean that you cannot see me or hear me? You can see me? Okay, and my screen? You can see the screen? You can see the screen? Okay. Okay. This is a WarpPLS website that I think you downloaded WarpPLS version 6 from this website. WarpPLS is a software that was developed by Professor Ned Cook in 2009. The first version of WarpPLS, WarpPLS 1, and he also improved and add different different features to WarpPLS, and now WarpPLS 6 already released, and we can use WarpPLS 6. I'm sure you downloaded WarpPLS 6 and install your computer. In this website, you can see a lot of YouTube videos about basic things and performing analysis by WarpPLS, and some advanced analysis by WarpPLS. So you can see different videos here, and also you can find some publications about methodological discussion on WarpPLS, philosophical and mathematical foundation of WarpPLS, and also some application empirical studies WarpPLS. And here you can see our paper with Professor Network that published in Journal of Sustainable Tourism. So you can see some dissertation using WarpPLS. So a lot of different resources you can find in WarpPLS website. And also this is weblog, WarpPLS weblog, and you can see different webinar, workshop, some question and answer by Ned in this weblog. So you can refer to these two websites if you have any question. Also, you can send email to me if you have any question about WarpPLS, using WarpPLS for your work. Okay, this is just I want to show you this one. And now let me open WarpPLS. Okay, when you click on WarpPLS shortcut, you can see this page. I hope all of you can open this one and proceed to use software. Okay. WarpPLS is a very powerful and easy to apply software, and just you need to follow these 5 steps to create your framework and to see the result of your analysis of your model. Okay, I start from step 1 to create a simple model and see how we can get the result for this simple model for assessment of measurement model and structural model. Okay. For using WarpPLS, you need to follow these 5 steps. Click on proceed to step 1, and when you click on proceed to step 1, ask you about open project file. If you have a project file model that you already created, you can open project file. If you don't have and you want to create new project, you need to click on create project file. If you click on this one, you need to select a folder that you want to save your model. Okay, let me select, for example, in desktop, I select this folder. This is WarpPLS Workshop Newcastle. Okay, I select this one and just exercise 1, called this file exercise 1. Whatever you want, you can name your project. Okay, save exercise 1. Okay, this is first step. We pass first step and create the model. Go to step 2. Click on proceed to step 2. Okay. In this step, we need to read the our data set. WarpPLS can work with the different types of Excel file, text file or tab delimited file, and comma delimited file or CSV file. All different types of data set can be read by WarpPLS. So now we need to read our data file. Click read from file. Okay. Here I have different data file, but just here you can see one data file because the extension here is just text. If we change the extension to all files, so we can see all the files with different extensions. Okay. Exercise 1, this data file for exercise 1. Click on and open this one. Okay, just next and finish. No need to do anything for this part. Here you can see your data. You can look at your data set and see, okay, your data set is okay, there is not any problem in your data set, and you can check your raw data file. If it's okay, just click on yes. So you pass second step and ready to go to step 3. In step 3, you can do some pre-process data analysis and pre-process data activity. You can check for missing value and some identical column and no variance column or data. And finally, in this step, your data will be standardized and create standardized data for to start analysis. The data that we use in PLS should be standardized. So the first step to start analysis with the different software in the PLS is a standardization of data. So, okay, if you click on OK, you can see a standardized data here. This is your data, but not raw data, it's standardized data. Okay. If it's okay and look correct, you can click on yes and go for next step. So you can see the very easy 3-step. Create your framework, read data, and do some pre-process analysis and check in your data set. And step 4, when you click on step 4, this step, okay, define SEM model. In this step, click on define SEM model. Okay. Here you have a white window to create your framework in this white window, and some option here. Some option here to create latent variable, direction between latent variable, and moderating effect, moderating link that later I will discuss and will show you. Okay, so the first thing is latent variable option. Click on latent variable option. The first one is create latent variable. Click and click on white window. Okay, now you have this window here. In first exercise, just we have 3 latent variables. The first one is positive perception of resident toward the tourism development. The second one is negative perception of resident toward tourism development, and the last one is support for tourism development. And perception of resident effect on support, right? So we want to create 3 reflective constructs. First one is positive perception, and here you have all indicators based on the data set that you already read, and you have the items here. Okay, positive perception, positive perception. So you have 5 items to measure positive perception of residents toward tourism development. You click on add to add these items to this box. This box is for items of this construct. So you add from this one. If you wrongly add another item, this is negative perception, but it's not doesn't belong to positive perception. Just you can remove and return back to this box. So now you have 5 items that measure positive perception. Here you can select reflective and formative type of construct, but this construct is and these items are reflective. So keep reflective and just save latent variable setting. So the first construct will be appeared here. Now create second one, negative perception. Negative perception include okay, click add first one, -1, NP1, NP2 add, NP3, NP4, and NP5. And also the type of construct is reflective, so just save. Okay. Inside the construct, you can see R in parentheses and 5i. It means the type of construct is reflective, and this construct has 5 items. 5 items and reflective. Okay. If, for example, you want to change to formative, click on latent variable option, edit latent variable, click, and you can change to formative, for example. Okay, I just want to show you. Save. Okay, here you can see R change to F. F means formative, but again, we want to change to reflective. Okay, so we have 2 latent variable, positive perception and negative perception, reflective with 5 items. And the last one is support for tourism. And we have 6 items to measure support. Support 1, add. 6 items to measure support for tourism development, and this construct also is reflective construct. So save. So now we have 3 latent variables that these 2, positive perception and negative perception, affect on support for tourism development. So we need to link between these 3 variables. To create direct link between variables, click on next option. The first one was to create latent variable, edit latent variable, delete latent variable, and move latent variable. And the next one is create direct link, delete, and delete all direct link together. So create direct link, the first one. Click on first latent variable and the second one that the arrow should be a point to. Okay. The arrow appeared here and okay. So now you have the framework including these 3 reflective items, reflective construct. The first one is positive perception with 5 items. Negative perception with 5 items, and support for tourism development, reflective construct with 6 items, right? So now you created your framework and your framework is complete. If you have another variable, you need to create another latent variable and linkage and link between different variables. Okay. After creating your framework, just in first option, Just save model and close. Okay. Just click. Now you create your framework and go to the last step. Last step is performing analysis. Perform SEM analysis. This is the last step when we work with the WarpPLS. If click on perform SEM analysis or SEM analysis, okay, this is the result of your analysis. You can see the result of part of result of the structural model, but for assessment of measurement model, we need to check result here. Okay. Okay, I'll show you. Okay, this is your final result. For assessment of your framework using PLS, you need to pass two steps. Assessment of measurement model and assessment of structural model, right? For assessment of measurement model, the first step is when you click on view, you can see many results here, right? The first one is check the outer loading or factor loading, right? For outer loading, you need to click on this option, view indicator loading and cross loading. Also, you have a lot of options here. Just click on first option, combined loading and cross loading. This is for first step. Okay, this is for first step. For positive perception, you have 5 items, and you can see the loading within the bracket, within the parentheses. So the outer loading for positive PP1 is 0.77, 0.76, 0.662, 0.815, and 0.849. Just one item is lower than 0.7. We need to look at the CR and ABE of positive perception. If CR is higher than 0.7 and ABE higher than 0.5, we can keep this item. If it's lower than 0.7 or ABE lower than 0.5, we need to remove the item with lowest loading. So now we can go for next one. Next one, negative perception. All items, all loadings are higher than 0.7. So it's okay. And for support. Also for support, we have just one item lower than 0.7. So we need to check CR and ABE. So this is the first step, assessment of loading. Okay. For next step is we need to check construct reliability or internal consistency. Okay. For internal consistency and construct reliability, this part, we go to other option, view latent variable coefficient. We have a lot of information here. If you click on this one, okay. Composite reliability, Korenbach alpha. For these three constructs, composite reliability and Korenbach alpha are higher than 0.7, right? So CR and the Korenbach alpha are acceptable for construct reliability and internal consistency. Also AVE, here you can see AVE, and the AVE higher than 0.5. So we can pass, we can establish construct reliability based on composite reliability and Korenbach alpha, and convergent validity based on AVE, AVE higher than 0.5. So for measurement model, for assessment of measurement model, we can establish a construct reliability and also convergent validity. Okay, and the last step for assessment of measurement model is discriminant validity. For discriminant validity, we need to check Follin-Larker criterion and HTMT. Okay, Follin-Larker criterion, we can see in another option, view correlation among latent variables. If you click on this one, here you can see correlation, and here you can see square root of AVE. Square root of AVE shown on diagonal. So this one is square root of AVE of positive perception in parentheses. This one is square root of AVE of negative perception, and this one is square root of AVE of support. So this square root should be higher than correlation of positive perception with other constructs. This is the correlation between negative perception and positive perception, and this one is correlation between support and positive perception. So you can see square root of AVE of positive perception is higher than these two correlations. This one also, this is correlation of negative perception and support, and this one is correlation of negative perception and positive perception. Okay. Also, this one is higher than these two, and this one is higher than these two. So this correlation, this is a Follin-Larker criterion for assessment of discriminant validity, and we need to check square root of AVE with correlation. But HTMT, unfortunately, WarpPLS 6 in recent version and also previous versions didn't provide the HTMT. Maybe in the next version, the developer think to add HTMT for assessment of discriminant validity. But still, you can go ahead with the Follin-Larker criterion from WarpPLS software. For reporting the result of, let me bring one of my, okay. This paper is published in tourism management last year, and we use WarpPLS for this paper. Here you can see the way we need to report measurement and structural model. Okay, in this study, this is our framework. In this study, we have 6 independent variable or endogenous construct and 3 dependent variable. We have 18 hypotheses for this study. Okay. For assessment of measurement model, we have 9 reflective constructs. So we need to report 9 reflective construct reliability and validity for this 9. All right. For assessment of measurement model, you can create a table like this. Okay. We have 1, 2, 3 construct here. 1, 4, 5, 6, 7, 8, 9. Okay, we created all these constructs. We put all these constructs here. Also, you can put abbreviation of each construct and provide a table with the exact item, and or maybe you can use abbreviation for this table assessment of measurement model. But you can put the items here. The loading indicator reliability can be assessed based on this loading. CR is for assessment of convergent value, assessment of construct reliability, or you can add Kornbach alpha or rho A. Also, WarpPLS provide rho A for reflective construct. You can use rho A, and AVE for convergent value. So you can put all these values for assessment of measurement model, reliability, and validity. But for discriminant validity, you need to create another table, and you can transfer this table and use this table for assessment of discriminant validity. Here in diagonal, you can see in bold values are square root of ABE, and compared to other correlation with other construct. And the square root of ABE should be higher than correlation with other construct. So you need to report discriminant validity table from the software. So this is a basic part for assessment of measurement model and for assessment of measurement. Okay, one thing, when you when you perform analysis, okay, here you can view all results, including loading and CR, ABE, okay. Here you can save all model estimated into a tab delimited text file, and you can open this file in Excel and transfer different parts of result that you need for reporting in your paper and in your thesis. If you click on this one, okay, result exercise 1, click on save. Here you can see the result, and the text limited file you can open in Excel and transfer to Excel file, change, convert to Excel file, and use for reporting your result. Another thing that I should mention here is, okay, when you perform analysis, here in Explore, you can see the row A. Okay. Here, Explore, Digestra, consistent PLS output, and you can see the result of row A here for positive perception, negative perception, and so forth. So we can report this result for row A, addition to composite reliability and Kornbach for assessment of construct reliability or internal consistency. Okay, and let me check the structural model result. So this was the result of measurement model of reflective construct. Measurement model assessment of reflective construct. For a structural model, we need to report R square, Q square, effect size, and pad coefficient. Again, go to this part, view latent variable coefficient. As I mentioned here, we have a lot of information. Okay. Okay. Here, the software provides the R square and adjusted R square. So you can report R square and adjusted R square here. The R square is 0.214 and adjusted is 0.201. So it's acceptable for behavioral science. And the Q square. The Q square is predictive relevancy of predictive capability of this framework. The Q square is 0.222, so it's higher than 0. So is acceptable, can confirm the predictive capability of this framework. This is two criteria for assessment of R square and the Q square. Okay. Now we need to check two more things: pad coefficient and significance of pad coefficient. If you click on this one, okay, this one, pad coefficient and p-value. Okay, here you can see the pad coefficient. So the effect of positive perception on support is positive, right? And the p-value is lower than 0.001. So this effect is positive and significant. And the effect of negative perception in support is minus 0.162. And the p-value is 0.029. It means lower than 0.05. So two relationship and two path coefficient are significant. Okay, if we hypothesize positive perception on support based on the theory, positive perception has positive effect on support and negative perception has negative effect on support for tourism development. So our hypotheses also are supported based on these results because these two path coefficients are significant and in same direction with hypothesis. So this is the result of assessment of a structural model for this framework, including 3 reflective construct and the assessment of a structural. Okay, just one thing I want to add here. WarpPLS, one critical things that WarpPLS provide is we can check the statistical power of our framework and minimum sample size requirement for this framework. This is always an issue when how we calculate the minimum sample size for our framework. WarpPLS based on 2 very advanced statistical methods called inverse square root method and gamma exponential method. Calculate minimum required sample size. Okay, to calculate minimum required sample size, we need to put the minimum significant path coefficient here. The minimum value for significant path coefficient is 0.16. For our framework. Yeah, you can see here 0.16 and 0.41. So the minimum one absolute value is 0.16. Okay. So we put 0.16 here and the power of 0.8 power for the power of analysis. Okay, so the minimum sample size to get 0.8 power based on this value of path coefficient is based on this method is 227, and based on this method is 241, 42. So based on this method, minimum sample size to get the 80% of 0.8 power for this framework is 228 or 242 based on these 2 different methods. So we calculate minimum sample size based on this. Okay. Let's stop for this session and have a break for 15 minutes maybe, and after 15 minutes we can come back and continue with the assessment of formative and the mediator and moderator. But if you have any question for this part, you can type your question and before going for 15 minutes break. Any question? I think no question. Okay. So now in my time is 12, but your time should be 3 p.m. So we will come back after 15 minutes. Okay? Okay. Thank you. Before starting the second part, there was a question about sample size in last session. Now I saw it. Does the sample size affect the result of PLS-SEM? Of course, affect. So we need to meet the minimum sample size requirement. And what's the sample size appropriate to achieve a good result? We need to calculate the minimum sample size. There are different methods to calculate the minimum sample size. Can you hear me? It's clear? Okay. There are some traditional rules, especially in PLS, that is not now, based on the recent literature, is not a right rule of thumb. For example, one of the rule of thumbs, traditional rule of thumbs, is the 10 times rule. Based on this rule, the minimum sample size for PLS should be 10 times of highest number of or largest number of arrow appointed to a specific construct. For example, in our framework, the largest number of appointed arrow to one construct is 5, and another construct is lower than 5. The highest and the largest number is 5. So this rule of thumb says the minimum sample size is 15, right? 5 times 10. But now the recent literature reject this rule of thumb, and no longer this rule of thumb is acceptable. Also for PLS, we need to check based on the power of analysis. For example, this is okay. Here in our recent paper that before I mentioned, data characteristic and the sample size, we suggested based on recent literature, especially this paper, Cork and Hadaya 2018, they suggested using these two methods, the inverse square root or gamma exponential method, or also these two methods are under umbrella of power analysis. We need to calculate the power of our framework, and the result of power analysis should confirm at least the power of 0.8 based on our sample size. So the acceptable power for to calculate minimum sample size is 0.8. So we can use these two methods. These two methods are available in WarpPLS that I show you here. We can calculate the okay. I thought I shared the screen. In this paper, here we suggested use power analysis, and these two methods suggested by Cork and Hadaya. And WarpPLS, you can calculate the statistical power and minimum sample size based on these two methods. These two methods suggested by Cork and Hadaya 2018. Another method to calculate minimum sample size, if you don't have access to these two methods and you cannot calculate based on these two methods, is using G power. And by using G power, you can calculate minimum sample size based on your framework, number of latent variable, and the complexity of your framework. So you need to follow the minimum sample size at least to get the power of 0.8. So minimum sample size is a critical issue, and without meeting minimum sample size, your result can be a wrong result. Okay. And I think there is another question. Can you add demography as a latent construct? If yes, how do you do that? Demography means the demographic variable, like age and gender. I think, yeah, you can add as independent variable, and also in some situation as a dependent variable. In WarpPLS, for independent variable, you can easily add demographic variable like age and gender as an independent variable, but just there is one limitation. When your variable is dichotomous variable, it means a variable with just two levels, like gender, male and female, or yes or no answer, yes and no answer. It's not possible to perform PLS by using a linear algorithm. Most of the PLS software use linear algorithm for inner model, so it's not possible to have dichotomous variable as a dependent construct, as a dependent variable. But WarpPLS using some non-linear algorithm, it's possible to do. If I will show you later how we can do. But maybe another question for this: when we have demographic variable like age and gender, we can identify the construct with a single item. So we can put gender or age as a single item to create the construct. So we can add the construct and latent variable in the framework. Okay, if I understand correctly this question. Okay, let's continue. This is the framework that we perform the analysis and assess measurement model and structural model. But all constructs in this framework were reflective construct. So we assess reliability and validity, and also a structural model, R square, Q square, and the pad coefficient. Just one thing I want to add in WarpPLS. This is one important capability of WarpPLS. WarpPLS sometimes known as a nonlinear PLS software. This is because in WarpPLS we can select different algorithm and different inner model algorithm. So, okay, here again in the setting part, view or change general setting. If you click on this part, you can see different boxes here. The first one, you can select the outer model algorithm or measurement model algorithm. If you click on this one, you can see a lot of different algorithms that you can select for your analysis. These parts are all common factor algorithm or factor-based algorithm. This is mode A and mode B, the common algorithm that used in PLS. And PLS regression is another algorithm that is default in WarpPLS for outer model. Also, you can select the algorithm for inner model. You can select between linear, WarpP2, and WarpP3. Linear is linear algorithm that most of PLS software use this algorithm to calculate, to estimate the parameters. So in this, based on this algorithm, we assume linear relationship between constructs in a structural model level. But also you have another two options, WarpP2 and WarpP3. VARP2 represents relationship between construct as a U-curve or J-curve relationship, like logarithmic relationship or quadratic relationship. So VARP2 is representative of the U-curve or J-curve relationship between construct. And VARP3 represent or assume S-curve relationship for between S-curve relationship between construct. So if you select VARP3, if there is S-curve relationship between construct, by applying VARP3, the software can detect this S-curve relationship. But VARP3 also include linear and VARP2. So if the relationship between construct is linear or is something similar to U-curve or J-curve, also the software will detect linear or line for this relationship, or the U-curve or J-curve if the relationship is similar to if the relationship is quadratic or logarithmic. So the default for WarpPLS is WarpP3, and using WarpP3 we can make sure the real pattern of relationship will be detected by software. Okay, let me just play with this different algorithm and see what happens. Okay, if we change, for example, inner model algorithm to linear and say, okay, and proceed to step 5 again. So it means again perform SEM analysis. You can see the relationship here between negative perception and support now is non-significant, right? And the R square is lower than last time. Okay. Just I keep this one, and again, okay, keep this result based on linear, and change the setting to VARP3. Say, okay, when we change the general setting, also we need to change individual, because WarpPLS give opportunity to us to set algorithm for each relationship. So we change all individual relationship to also VARP3, and run the frame. Okay, you can see the difference between these two framework. Okay, this is linear relationship. The path coefficient for effect of positive perception of support is 0.34, but significant. But for nonlinear, the path coefficient is 0.41 and significant. For negative relationship, the path coefficient is, for linear, the path coefficient is minus 0.07 and non-significant. The p-value is 0.2. But here, assuming nonlinear relationship, the path coefficient is significant, right? Based on this different pattern of relationship, we recently published a paper in Journal of Destination Marketing and Management. And in this paper, we discussed the relationship and the modeling of resident perception relationship with the support. Is our question was this relationship is linear or nonlinear, And we discuss here and show the evidences here that this relationship, we apply 3 different cases and show the differences and show the pattern of relationship, especially for negative perception and support is nonlinear instead of linear. And we discuss previous study, because previous study always there is some different results. Some studies found a positive relationship between negative perception and support, some of them negative perception and some non-significant relationship. And here we show this different result from previous studies because of nonlinear pattern of negative perception to support. You can see different pattern of negative perception to support. So here we can see the plot for its relationship. For example, for linear negative perception and support, plot with the data point. Okay, this is the plot with data point. Okay, you can see linear relationship is very similar to a line with the slope of very low or 0. So the relationship is non-significant. But if we can see exactly this graph for nonlinear effect, okay, so you can see, okay, if we assume, if we use nonlinear algorithm, you can see we applied back 3, but the pattern is U-curve. So the best fitting curve is detected by WarpPLS software. But here you can see the relationship is nonlinear compared to linear. When we assume nonlinear, we can get significant relationship between negative perception and support. This is one of the most important capability of and the benefit and advantage of WarpPLS. And in real situation, most of the time the relationship are non-linear compared to linear relationship, because linear relationship is not in real situation. Most of the time we can create linear in laboratory, but not in real world. In real world, most of the time the relationship are non-linear. So this is the important benefit of WarpPLS. We can select the nonlinear algorithm. Okay. Always don't forget to save project when you create a project. Save project, and if you don't save project and go to create another one, you lose this one. You may lose this project. So please save project and go for next step. Okay, now we save this project, and let's continue for formative measurement model. For assessment of formative measurement model, if our framework includes formative construct, 2 things we need to consider. The first one, we need to know the criteria for assessment of formative measurement model is different with reflective. So we need to apply different criteria for assessment of formative measurement. This is the first one. And second one, when we want to apply formative construct, before performing analysis, before assessment of measurement model, we need to check external validity or redundancy analysis. What does it mean? When we have formative construct, for example, satisfaction, we decide to measure satisfaction based on formative items. We need to collect, we need to add one more question in our questionnaire to measure overall satisfaction, addition to formative items. This overall item, or sometimes reflective items, but overall items preferred, we add overall item. For example, we measure satisfaction in our questionnaire based on question regarding service quality, personnel environment, and accessibility and equipment. But we add one question: overall, are you satisfied with this hotel or not? Okay, and ask the respondents to respond to answer this question also, addition to formative. Why? Because we need to check external validity of formative or redundancy analysis of formative constraint. Before performing analysis, before including formative in the framework, we need to check this relationship between formative construct and satisfaction with reflective items or overall items, like this one. We measure satisfaction, but here just can be one item instead of reflective, just one item, overall item to measure satisfaction. The relationship between formative construct and overall item should be at least 0.7. It means the item we include to measure satisfaction, the formative items we include to measure satisfaction, at least should explain 50% of variance of satisfaction. When we measure satisfaction with overall item, and this relationship is 0.7, a square path coefficient, square path beta coefficient represent the explained variance by formative construct on this overall satisfaction. This overall item represent whole meaning of construct. So when the relationship is 0.7 and higher, it means this formative construct can at least represent 50% of whole meaning of satisfaction. So we need to do this external validity or redundancy analysis to make sure we included at least 50% of required item to measure satisfaction. So this is the first step before including formative construct to the framework. After including formative construct, we need to check VIF, variance inflation factor, or collinearity between items of formative construct, and the collinearity should be lower than 5. Literature suggested different values. Some of the literature mentioned for formative construct VIF lower than 2.5, but most of literature suggested lower than 5 is acceptable. So at least VIF or collinearity should be lower than 5. If it is the first step after including the formative measurements model in the framework, it's the first step to assess formative measurement model. The VIF should be lower than 5, or collinearity between constraints. The next step is assessment of outer weight. The outer weight of formative construct should be significant. So it means the p-value should be lower than 0.05, or if we apply other methods to assess significance of outer weight, based on these methods, outer weight should be significant. So this is the second step for assessment of formative measurement model. So the first one is VIF lower, or collinearity, multicollinearity lower than 5. And the second one, outer weight should be significant. But you remember when we discuss formative measurement model, each item has a specific role and very important to establish formative construct. So we cannot easily remove one item from formative construct. So if the outer weight is not significant, we can check the outer loading. And if the outer loading is significant, still we can retain this specific item for formative construct. So VIF or multicollinearity is first step. Second step, check the significance of outer weight. If the outer weight is not significant, we need to check the significance of outer weight. Okay, just one thing here I want to add. For discriminant validity assessment, all criteria so far proposed by the literature for assessment of discriminant validities for reflective construct. We don't have criteria for if our framework includes a formative construct. We don't have any criteria to assess discriminant validity for reflective and formative construct together, or similarity between reflective and formative construct. Cork and Lin 2012 introduced full collinearity, and full collinearity includes the vertical and lateral collinearity. Also here, Hare and his colleague in this paper suggested when formative construct, including the framework, we need to assess multicollinearity between construct, because here mentioned Follner-Larker just apply for reflective construct, but we don't have any check for similarity of formative construct with other reflective. So suggested assessment of collinearity between construct. We presented the paper in Macau conference last year, 2017, PLS conference in Macau. And we did a simulation study, and we compared Follner-Larker HDMT, two different types of HDMT, and full collinearity, when our framework includes reflective and formative construct. Here, we, based on this simulation study, we concluded if the framework includes both formative and reflective, full collinearity is a good criterion to assess discriminant validity with a threshold of 3.3. If we assess full collinearity and collinearity between construct, we consider collinearity lower than 3.3, we can get better result even compared to HTMT based on this simulation. At least collinearity can be applied for any complex framework, including reflective and formative, and we can use a collinearity to assess, full collinearity to assess discriminant validity. Full collinearity is provided by WarpPLS. Here, if we look at the result again, latent variable coefficient, you can see here WarpPLS provide full collinearity VIF for each construct, also for reflective construct. And the value is 1.13, 1.00, and 1.138. So these values show we have no problem of discriminant validity of full collinearity even for these reflective constructs. When model include formative constructs, so we can use this for collinearity to assess discriminant validity. Okay. So this is criteria for assessment of formative measurements model, and this paper we applied the WarpPLS, and this the framework of this paper, okay, includes some demographic variables, characteristics like nationality, Malaysian and non-Malaysian, gender, age and education, economic factors, income and spending money, and the facility and landscape. We have some single item construct, as I explained. Social demographic variables are single item construct: nationality, gender, age, and education. Also, income and spending money are just they have one item. So these type of construct called single item construct, and we have two latent variable. Two construct with item. These two constructs are formative. So we have, and also in this framework, perceived crowding is a formative construct. So we have 3 formative construct and 5 single item construct. Here, this is the result of assessment of measurement model. We don't include the single item because we cannot assess single item construct in measurement level. Just include 3 formative construct, and for formative construct we reported VIF, or collinearity between collinearity of items. So the VIF should be lower than 5. This is weight, so the outer weight should be significant. So you can report like this for measurement model assessment of formative construct. Put the weight here and the p-value. Also for this one, weight and p-value, weight and p-value. So you can see all VIF are lower than 5, and the weights are significant. Also, we report full collinearity for these 3 constructs, this formative construct, and the full collinearity VIF is 1.67 for facilities and landscape 1.43, and the perceived crowding 1.2. This is the result for the way to report result of formative measurements model. Okay, let's create a formative measurements model in say the first one. Second exercise, the third exercise is a file that I sent you is from this paper. Yeah, it's from this paper, including facility, landscape, and perceived crowding. So this is the data for this paper, exercise 3. So I tried to create this exercise and assess formative measurement model and structural model using WarpPLS. Okay. Okay. So again, proceed to step 1. Now you have data set, so you can follow me. Okay. Okay. Again, proceed to step 1. Click on step 1 because we want to create a new framework. Create project file. So this one is exercise 3. Right. Exercise 3. Step 2. Read from file. Okay. Here we can go to data file. Here we can see just one file with the text delimited file, text extension. If we click on all file, we can see all file, but we need exercise 3. Click on open, next, finish. So we can see this file here. Okay. Step 3, pre-processed data. Here you can see we have some missing value, and the software replace missing value here by mean, but you can select different missing value imputation method. Here is the mean replacement. Okay. Yes. And step 4 is for creating our framework. Okay, again, like before, we have gender. Okay. One gender is single item construct, just it has one item. For single item, doesn't matter, you choose reflective or formative. So we can go with the reflective. Create second one, also age is a single item and just has one item. Also income. Save. And spending money. Save. Okay, so now we have for single item construct. We have, okay, more facilities. Facilities formative, 10 items. Save. Landscape. Okay, but landscape and facility are formative. Okay, I will change for facility also. Save here. So you can see landscape is 7 item and formative, but facility I forgot to change to formative. So I click here and edit latent variable. Click on this variable and change to formative. Save. So now we have 2 formative construct, and the last one is perceived crowding. 1, 2, 3, 4, 5, 6, and also formative. And okay, now we create 7 construct. 3 of them are formative and 4 single item construct. But we before creating model including formative construct, I mentioned we need to check the external validity and redundancy analysis for formative construct, right? So we didn't do. But we collected data before, we collected data when we collected data overall item for each formative construct. So we need to create 3 more overall facility, right? So overall facility, overall landscape, and overall perceived crowding is the overall item that we included in our questionnaire. And collected data when we collect data for formative constraint. So say the next one is overall crowding, say, and overall landscape. Right. So we have these three. So before creating and finalizing the framework, we need to check the relationship between, okay, perceived crowding and overall landscape and overall landscape, overall assessment about landscape and overall assessment about facilities, and create link between them. Okay. So at first we need to assess these three and report in our paper. Save and close model. Okay. Okay. Here you can see the relationship between formative construct and overall single item construct. The beta value or path coefficient is 0.83. This one is 0.81. And this one is 0.78. So for these three formative construct, the relationship is higher than 0.7. So explained variance of formative on overall item construct is more than 50%. So formative construct can represent more than 50% of this constraint, whole meaning of constraint, right? So these all are acceptable. So we can include in our framework. So you can report this result in your paper and dissertation. Okay, if we want to do some modification in our framework, we need to go back to step 4. Click on step 4 and delete overall item, overall constraint. Delete, okay, perceived value, landscape, and facilities. And no direct relationship between independent variables and perceived value. Okay, now save model and close. And proceed to step 5 to perform analysis. Okay. Here we can see the result of analysis for this framework. This framework includes 4 single item construct and 3 formative construct. So first step is assessment of measurement model. Assessment of measurement model just for 3 formative construct. For formative construct, first step is assessment of VIF. Okay, VIF, we need to check here. Okay, here you can see indicator weight, right? If you click on indicator weight, okay, here provide weights for single item also, but single weight for single item is 1. So we cannot assess single item construct. But for this one, for facility, this is the weights for facility. Okay, the weights for facility, outer weights, and this is outer weights for landscape. And here in parentheses, outer weight for perceived crowding. Right? Okay. Here we can see the P. Here you have all information to assess measurement model of formative construct. You have VIF, you have p-value, and the outer weight. Okay, VIF for facility. Okay, you can see all VIF or full collinearity of formative items are lower than for facility, lower than 5, and for landscape, 5. For landscape are also lower than 5, and for perceived crowding, lower than 5. So you can pass the first step, assessment of VIF, and the VIF of formative items should be lower than 5. The second one is significance of outer weight. Okay, the outer weight of facility here, and the p-value. Okay, you can see the p-value or p-value are lower than 0.05. So the outer weights are significant. Just this one is a bit higher than 0.05. So we can check the outer loading, significance of outer loading for facility 2. Okay, and for landscape, all are lower than 0.05, and also for perceived crowding, all lower than 0.001. The loading, the significance of the p-value for outer weight of landscape and perceived crowding. Just for second item of facility, we need to check the significance of outer loading. So we meet acceptable VIF, and we check the outer weight and the p-value for outer weight. So just for facility, again, go to here. We have indicator loading or factor loading or outer loading for all construct, formative and reflective construct. Okay, just facility 2. Okay, just for facility 2, we can check the p-value of outer loading. The outer loading is, the p-value is lower than 0.001. So the p-value for outer weight is a bit higher than 0.05, but the loading, the outer loading, the p-value for outer loading is significant and acceptable. So we can keep all formative items for facility, landscape, and perceived crowding, and we meet all required criteria for assessment of formative measurement. Like previous model, we can assess a structural model. For assessment of a structural model, we need to check R square, latent variable coefficient, R square 0.216, 0.202, Q square 0.209, higher than 0, and effect size, a standard error and effect size for pad coefficient. Okay, before that, we need to check the pad coefficient and p-value. Okay, this is the pad coefficient. The pad coefficient, 2 of pad coefficient are not significant. So the effect of age and landscape on perceived crowding cannot be supported by the result of this study. So, but all the effect of gender, the effect of income, spending money, and facility on perceived crowding is, these effects are significant. But landscape and age cannot be supported. The effects of landscape and age cannot be supported by the result. Okay, and effect size for supported result. effect size here. Okay. Interesting things here. Okay. We show two windows together. Okay. Okay. The effect landscape and age is not significant. So the value of f square is very low for these two, 0.007 and 0.008. So it's much lower than 0.02. And also the p-value don't support this effect, right? But for what about other effect size? Gender is significant. The effect of gender on perceived crowding is significant. Income also significant. Facility also and spending money are significant. But what about effect size? Okay, effect size of facility, effect of facility on perceived crowding is moderate, higher than 0.15. So it's moderate and acceptable. Spending money is 0.021, very close to threshold, but still small and acceptable. What about income? Income here is significant, but the effect size is lower than 0.02. And also gender. The effect here, the p-value is significant, but the effect size is lower than 0.02. So for effect of gender and income, the p-values are significant and the path coefficient are significant. P-value are lower than 0.05. But the effect size, the value effect size, show very, very small contribution of these two variables on R square of perceived value. So these two relationships and these two hypotheses also cannot be supported. Even the path coefficient and p-value show the significant relationship, but the effect size is very small and lower than 0.02. So we need to report all these and discuss the result. Okay. So this is the assessment of a framework, including formative construct. Okay, don't forget to save the project. So we created two projects, one including reflective construct and one include the formative and single item construct. Okay, let's continue for, okay. Actually, I supposed to cover 3 more issues in for assessing PLS and using WarpPLS, but I'm not sure because now just we have 14 minutes to complete the second session. But I try very briefly explain these 3 topics and show you in WarpPLS how we can assess. Okay, the first one is higher order construct. A higher order construct for sometimes that we have a construct with some dimension. For example, a resonant perception. Resonant perception is a construct including some dimension. Resident perception toward environmental impact, toward cultural and social impact, toward cultural impact, toward social impact, and also economic impact. Right? So we have a construct including some items, some sub-dimension. And these dimensions measured by some observable items. So in this case, we have a second order and higher order constraint. Another thing is leadership. We measure leadership based on some dimension, and each dimension measured by and assessed by measured by some items. So we have a higher order construct including some dimension. And in the literature, there are different types of higher order construct. In this study, Ringle and colleagues categorized some study up to 25 models and study that they reviewed in their papers. They paper 5 of these 25 models, 20% of these models are reflective. They identify 4 types of second order constraint. These 4 types are reflective means the dimensions, we call this layer first order. Dimensions called first order. First orders are reflective, and also these dimensions reflectively create second order. So these 3 dimensions also are reflective items to measure and to establish higher order constraint. So we call this type of second order reflective. Second type, the first orders are reflective, but the second order is formative. So these 3 reflective constructs, these 3 reflective first orders create second order in a formative way. So these 3 establish higher order construct formatively. We call this type of construct reflective formative. Third type, or type 3, both the first one is the dimensions are formative, but these 3 dimensions reflectively create the second order. This type of higher order is very rare, and I think there is not strong logic behind this type of higher order, because if the items are reflective, if the items are formative to create dimension, how this item can be high correlated to the item of the second dimension and third dimension. Okay, and this dimension can be high correlated and reflective. But you can find some study based on this type of second order construct. And the last one is formative. First, the order and dimensions are, the nature of dimensions are formative, and dimensions or first orders formatively create second order. This is 4 common type of second order construct. But also there are some literature that present different types, and combination of reflective and formative in these layers. This is one of our paper we published in Journal of Hospitality and Tourism Management. And in this paper, we, this is perceived value, and the perceived value present measured by 3 dimensions: functional value, emotional value, and social value. But functional value is second order formative, emotional value is second order reflective, and social value is first order reflective. And we measure, we assess, we establish perceived value based on these very complex dimensions. So you can see this layer we have one formative, one reflective, and one reflective, two reflective and one formative that formatively establish perceived value. So it's possible to have a combination of reflective and formative, especially when we use some specific type of technique like two-stage approach to create higher order construct. But most of the study mentioned about these four common types of higher order construct. Okay. If we have a second order construct, how we can establish this second order and how we need to assess the second order construct. How we can establish, because actually when we add a construct in using PLS technique, it's not possible to have a construct without any items. So if we have a second order construct, we need to assign some observed items to this construct. Okay, so based on this, the common approach that the literature suggested to create second order, to establish second order, and assess second order is repeated indicator. Means when you create a second order with three dimension, and you measure each dimension based on some observed item, you need to put all these items of first order in second order. You can see here x11, x12, x13, x21, x22, x23, 31, 32, and 33. Put all in this level. So this method called repeated indicator, and it's very common in the literature. But this method faced a lot of problem and difficulties, and recent literature don't recommend this approach. Instead, the recent literature recommend a two-stage approach. For two-stage approach, is the best paper for this one is the paper published by Becker et al. 2012. In this paper, Becker suggested this two-stage approach, and compared different approach, and concluded these two stages is one of the best. And also there are a lot of other papers that discuss these different methods and compare two-stage approach with repeated indicators. And two-stage approach works much better than repeated indicator in different cases and different situations. So my recommendation is to apply two-stage approach. Okay, in two-stage approach, in first stage we calculate in first stage we just include first orders in the framework and calculate the score of latent variables based on calculate the score of latent variable in first stage. So we use the score of latent variables in second stage to create second order construct. So when we use two-stage approach, in first stage we don't include second order, just we include first order and create just calculate the score of latent variable and use these score for second stage. This is two-stage approach, and in different software we need to apply different method for two-stage. WarpPLS is very easy to create to apply two-stage approach. I'm not sure I sent to you this data file. Okay, let me check. This is exercise 5. Okay, and I think I didn't send you exercise 5, but let me just create and show you how we can calculate latent variable score in WarpPLS. Okay, and later I will send to you this data file also. Okay, so again, proceed to step 1, create new project, exercise 3, 5. Read data file. Exercise 5. We have this is data from this paper. Yeah, but just I try to create this part and satisfaction. Don't include other part. Just functional value with this dimension and satisfaction. Okay. So next and finish like before. Proceed to step 3 again. Okay. And define model. Okay. Here you can see for functional value, we have establishment, service, host provider, and price. And we have these 4 reflective construct. And these reflective construct formatively establish functional value. So we create establishment. With 5-item reflective, say. Second, we create service. 1, 2, 3, 4, 5. Create host. And the last one is price. Right? Okay. So we have 4 dimension of functional value here. Okay. Another variable is satisfaction. Satisfaction. We have 6 items to measure satisfaction reflective. Okay. So we have okay. We create just first level dimensions or first order construct for functional value. And in first stage, we don't put second order, just first order, and link first order to dependent variable without second order, right? But these 4 are dimension of functional value. This is first stage. Just save and close model. and run analysis. Okay. So in this step, we cannot assess a structural model because still we don't create a second order. A structural model is just relationship between final construct. For example, here perceived value is a third order construct, including these dimension, and each dimension has some sub-dimensions. Okay. But the structural model is just relationship, perceived value, and satisfaction. Okay. Here you can see just we report this relationship as a structural model. But in second order or third order construct, just we discuss we need to report measurement model assessment result. So here we have 5 reflective constructs. So we need to report reliability and validity for these 4 reflective constructs. Okay, I don't want to go through this one. Okay. Now I need the score of these 4 constructs to create second order. How we can do in WarpPLS. Okay. Now you perform this first the analysis in this first stage, and okay. For a score of latent variable in WarpPLS, after performing analysis in first stage, you can go to modify part. Okay, modify part in main window of WarpPLS. Modify. Okay. You can add one or more latent variable score as a new standardized indicator, or you can add all latent variables scores as a new standardized indicator. If you click on this one, all latent variable score will be generated together. But if you click on this one, you can select which one you need. Okay, select which one I need. Okay, I want establishment. I want service, add. I want host provider, add. And I want price, dimensions of functional value, add. I don't need satisfaction because satisfaction is first order. So just here, if you scroll down, you can see we have 4 new indicators. A score of establishment, a score of service, a score of host provider, and a score of price. So close and go to step 4. Now you can create new latent variable, functional value. Okay. Functional value based on these 4. These 4 indicators are score of dimension, but now you have as a single indicator for each dimension. But formattive, remember these 4 dimensions formatively establish functional value. Formative, save and close. Okay. When you create this one, now you have functional value as a second order using 2-stage approach with a score of these 4 dimensions and first order. So now you need to delete all these 3 dimensions because you already have the score of this dimension. Okay, and create link. Save model. Okay, so now you have final framework including 1 second order and the structural model relationship between second order and first order. In this step, you need to assess measurement model and structural model. Measurement model, you have one formative and one reflective. So for formative, use VIF and collinearity and outer weight to check collinearity and outer weight. And for this one, you need to check reliability and convergent validity. For discriminant validity, here you have just one formative and reflective. So you can check for full collinearity. And full collinearity is lower than 3.3 for both constraints. So this is the way that we can create second order constraint. Here's something here. Maybe some question, right? No. Okay. So this is for second order constraint. Okay, very fast, I want to show you two more things for assessment of mediator and assessment of moderator. Mediator, there are a lot of literature for assessment of mediator. Mediator is for some situation that one variable intervene or mediate relationship between one independent and dependent variable. For example, here, we know seawater temperature affect on number of incidents. We don't understand the reason behind this and the process, how and why seawater temperature can affect on number of incidents. Okay, so for this one, we include a mediator. Mediator uses number of swimmers. Seawater temperature has a significant effect or increase the number of swimmers, and the number of swimmers, increasing the number of swimmers can affect on number of incidents. So mediator here can explain the process of this effect. Okay, so in a lot of literature you can find the assessment of mediator and inclusion of mediator. Okay. But for assessment of mediator, how we can assess mediator? There are different methods to assess mediator. Okay, McKinnon they work in 2002, review at least 14 tests for assessment of mediator. And they categorize these 14 tests in three groups. The first group is causal steps, and the common method in causal step groups is Baron and Kenny approach. The second is the assessment of differences of direct coefficient and direct relationship before inclusion of mediator and after inclusion of mediator. And the third one is product of coefficient of indirect effect or assessment of indirect effect. See, the indirect effect is significant or not significant. There are a lot of story behind these three categories, but just want skip these stories and just show you. Okay, before that, for recently, several literature suggested the last one, assessment of indirect effect. For assessment of indirect effect, also there are different methods. For assessment of indirect effect, we can use Sobel test, Orion test, Goodman test. This is different tests for assessment of indirect effect, significance of indirect effect. And also for indirect effect, there are different method, delta method like Sobel test and Orion test, and using bootstrapping. One method for assessment of indirect effect is percentile or bias corrected bootstrapping. The recent literature by Hayes and Schwarzkopf, published in 2013. Okay. They assessed different methods, and they concluded that Baron and Kenny is very low power approach. So yeah, in this study, Baron and Kenny is very low power approach, and don't suggest to use Baron and Kenny approach. And for assessment of indirect effect, also Sobel test and like some tests like Sobel test, Orion test, and Goodman are very low power, also least powerful and trustworthy tests for assessment of indirect effect. They suggested to assess indirect effect, but using bias corrected bootstrap and percentile bootstrap. So the best approach for assessment of mediator is assessment of indirect effect, product term of A multiply B, or indirect effect using bootstrapping and resampling method. So this is the best method for assessment of mediator based on recent literature. Okay, just show you here. Let me open exercise 1 again. Okay. In exercise 1, I want to add something. Okay. I want to add two variables here. Community attachment. Community attachment measures 7 items reflectively, and another one is economic gain. Economic gain measured by 3 items. Right? Okay. These two new constructs. These two new constructs affect on positive perception, and positive perception affect on support. So create the link between this, right? Without direct link. Based on the literature, we know community attachment and economic gain improve positive perception, and positive perception create the support of residents for tourism development. Now want to see, okay, positive perception can work and can be a mediator between community attachment and economic gain and support, or community attachment and economic gain has just direct effect on support for tourism development. So let me create also direct relationship. Okay, to simplify, let me just delete this one and just one mediator here. Okay. So economic gain, want to see positive perception mediate relationship between economic gain and support or not. Okay, we create and save and close the model and proceed to step 5. Okay. When the model includes mediator, all steps should be done. We need to assess measurements model based on the nature of construct and assessment of structural model, R square, and all things. Just we need to add the assessment of indirect effect for mediator, economic gain, and support. Okay. Here you can see the indirect effect for from this table. Okay. Indirect effect with 2 segments. Indirect effect with 2 segments means you have just one mediator. So one segment is effect of independent variable to mediator, and another one is mediator to dependent variable. So when you have just one mediator between IV and DV, here you can find the result of indirect effect. Between positive perception and support, right? Between economic gain and support. Economic gain and support. We have one mediator with two segments, 1, 2, right? So we can see this is the value of indirect effect. So the indirect effect between economic gain and support is 0.204, right? We need to check the p-value for this indirect effect. If you scroll down, okay, this is p-value for indirect effect of paths with two segments. This is the p-value for indirect effect from economic gain to support. So it's lower than 0.001. It means this relationship, this indirect effect is significant. It means positive perception mediate relationship between economic gain and support. Okay. Also in the result, you can see the effect size for indirect effect. This is effect size for this indirect effect. And this effect size is higher than 0.02, but lower than 0.15, so can be considered small, but significant. So based on the result of indirect effect, you can assess mediator. Later, you can go through this table, this figure. This figure is from Zhou 2010, and here identifies some different types of indirect effect. If the indirect effect is significant and the sign of indirect effect and direct effect is similar, same, this mediator called complementary mediator. But if the sign of indirect effect and direct effect are different, this mediator called competitive mediator. Here, in our result, indirect effect is positive, 0.20, positive and significant. And direct effect is negative. Direct effect is negative between economic gain and support. So this indirect effect and direct effect based on this figure are competitive mediator. But if also this direct was positive and the indirect also is positive, so this mediator will be called the complementary mediator. But here is competitive. So this is the assessment of mediator and indirect effect in WarpPLS. Okay. And the last one is assessment of moderator. Okay. What's the moderator? Moderator is for some situation that we know we have moderator here for the relationship between X and Y. What does it mean? It means that for two levels of this moderator, for example, this moderator is gender for female and male, or is company size for large company and small companies. Okay, we add this moderator. It means the relationship between X and Y is significantly different for large company and small company. If the interaction effect here is significant, it means the relationship for large companies and small companies are different. If the interaction is not significant, it means there is not any significant difference between a large and small company for this effect, right? So when we hypothesize moderator, we need to be very careful. Just simply, we cannot say, okay, M moderate relationship between X and Y. No longer acceptable for most of reviewers. You need to clearly mention, for example, the effect of X on Y is stronger for large companies or weaker for small companies. So this is the way that you can hypothesize moderator. There are different methods for assessment of moderator, interaction effect, the method suggested by Chin, product indicator approach, and another method is again two-stage approach and hybrid approach and orthogonalizing approach. There are 4 different methods for assessment of interaction effect. But WarpPLS use two-stage works in different situation and can be considered as one of the best method for assessment of moderator. And also WarpPLS provide the plot for this relationship, for the plot for relationship for low level and high level. So you can see the difference between low level and high level, addition to significance of interaction effect. Okay, let me create and show you how we use moderator in WarpPLS. Okay. In this data set also we have gender as the moderator, so we need to go to again step 4. Sorry, step 4, delete this one and create new latent variable. Yeah, we have gender here. We need to create gender for moderator and click on moderating link. If you click on moderating link, create moderating link, click on moderator and click on the relationship that you want to assess. Okay, this interaction effect automatically will be appear. So now you have gender as a moderator in this frame. Okay, save model and close. Okay. Here you can see the path coefficient for the interaction effect is not significant because p-value is 0.31. It means gender doesn't moderate relationship between positive perception and so on. Let's try for negative perception and see what happened for negative perception. Okay. Also for negative perception is not significant. So gender is not a significant moderator for relationship between positive perception and support. You can see, you can interpret based on the result of interaction effect here, or also you can see the result here is for interaction effect. So it's not significant for both, right? And also you can see the plot of relationship. Okay, let me change setting for moderator to, okay. You include moderator in this framework, but you want to set algorithm for moderator in linear algorithm. But for main model, you want to go by Warp3 and null. You can change individual relationship. You can keep these two as a Warp3, and if click on this one, you can change to linear, and you can change to linear for moderator. And again, go to step 5 and perform. Okay, still not significant. You can see the plot for here. Okay. WarpPLS provide different and very complex and rocky graph for rocky 3D, rocky 2D for moderator, and you can see when the moderator increase, you can see how the relationship changed. Then you have different plots for moderator here, but one of the best plot here is, okay, you can see two line for low gender and high. The low value of gender is male and the high value is female in our data set. So this is the relationship between positive perception and support, the red one for male and the black one for female. You can see there is not a significant difference between these two, and the slope and the path coefficient are very similar. So the moderator is not significant, gender is not significant moderator for the relationship between positive perception and support. I tried very briefly show you and cover higher order construct and mediator and moderator. Of course, if we had more time, we could go through each step and higher order, mediator, and moderator, and we see how can work in different situations. But just we had limited time, so sorry for very brief explanation in these three parts. Okay, if you have any question, I'm here to answer your question. Okay. Okay, I can see some question here. Okay. Can it be inferred that it's appropriate to check the full collinearity always? Yeah, my suggestion is to check full collinearity always, even you don't have formative construct and just you have reflective. The result of our simulation showed, I hope. Now we are working in another paper and do a bigger simulation, and we hope can publish this paper in a good journal. So the result of the previous simulation showed that even compared to HTMT, full collinearity can work well. So you can use for all situations. Another question, what's the minimum number of latent construct? There's not any restriction or requirement for minimum number of items in PLS. So even you can have just one item to measure, especially for reflective construct. For formative construct, you need to add the items to get and to achieve 50% of explained variance. So you need to add the item as much as you can based on a comprehensive literature review. But for reflective, even you can work with single item construct. But some literature discuss the problem with single item, but there is no limitation PLS for number of items. Okay, and another question. Your slide, you presented the two main types of mediation, namely simple and multiple mediation. Over moderation, I didn't see the type of moderation. Simple and multiple mediator means when you apply several serial mediator, some sequential mediator, or parallel mediators can be considered and can be called multiple mediator. And also for moderation, you can add the combination of some moderator, two moderator together. This is called three-way interaction. So you include two moderator, so you have 4 different situations, not 2 situations, and you need to compare these 4 situations. So you can have also complex moderator. You can have any complex model with mediator and moderator, but this need to be justified based on your framework, your literature and theory that you apply. I want to know if we have anything called multiple, moderation. Yes, how is that? For performing analysis, we need to do and create some, for example, for three-way interaction, if we have 2 moderator, we can use both interaction effect and multi-group analysis together. For example, in this paper, this paper we published in tourism, but I didn't use WarpPLS in this paper. I used Smart PLS. But for this paper, we assess moderated mediation. We assess a mediation, but also we run multi-group analysis to compare these 2 different framework. These 2 different frameworks and compare the result of mediation for this. So this can be called moderated mediation. But for complex mediator and complex moderator, we need to look at the type of this situation, and based on the complexity of and combination of mediator and moderator, we need to apply different methods. Okay. I cannot see any other question. If you have any other question, most clear. Okay. No question. Okay. Thank Thank you very much. Thank you for attending this webinar. I hope you get something useful to apply WarpPLS. I know was very rush webinar, and we talked especially about something very briefly. There are a lot of videos and different resources, especially in this website, WarpPLS website. If you are interested, you can go through the videos and yeah, can go through this video and see different features of WarpPLS. If you have any question, also you can send to me. My email address is this one, and I will be happy to answer your question if I can. Okay, thank you very much.